understanding exactly how this works is really important. And unfortunately, it's one of those things that it's easy to learn an overly complex Byzantine set of rules for how things work. But there's actually a simple way to think about it. So the way to think about this is as follows. Every variable in Java, when you declare one, has a compile time type, or I sometimes call it a static type, and that thing never ever changes. So for example, when I say living thing LT1, I get a box, and this is a memory box, it's 64 bits, and it can only ever point at a living thing. Now every variable also has a dynamic type, sometimes called a runtime type, and this is the type specified at instantiation, that is when you say new. And it's equal to the type of the object being pointed at. That's what we mean by runtime type. So at this point, I haven't instantiated anything. So the dynamic type we'll just note as null. Along comes this next line of code. We make a new fox, and we say LT1 equals that. So a new fox gets created. We copy its address into LT1. Here's that creature. And now we have a dynamic type. It's fox. It's the type of the object being pointed at. And so we'll continue. So next comes animal A1 equals LT1. In this case, we get a new box that holds animal references. Its static type is animal, and it never changes. In fact, look at that. It's like inscribed right on the box. Can't get rid of that. And its dynamic type is fox. And we can also have variables of static type fox. That's fine. So I make a variable with static type fox. It also points at fox. And in this case, the static and the dynamic type are both fox. Lastly, we decide LT1 is now going to point at a new object, which is a squid. So the static type, of course, does not change because it never does, but the dynamic type is now squid. Okay, great. So what? Well, this is the rule then. If you know the dynamic type of something, then you know what happens with an overridden method. So suppose we call a method of an object using a variable which has compile time type x and runtime type y. So for example, compile time type list and runtime type slist, as shown here. Then if it is the case that the dynamic type overrides the method, then the dynamic type's method will be used instead. And that's something known as dynamic method selection. This term is a little bit obscure. It's not totally standard, but I don't really have a great term, so we'll use it in our course. So in this case, whenever we call something, even though we're using the variable s1, which is this variable right here, because of the fact that the slist class overrides it, we use the dynamic types method instead. That's what you need to know.